is the same Jimbe test that we started with, okay, where you were looking at the determinants of demand in the alcoholic beverage unit. It's the same thing. So this entire data set, you can read the story, but you know the story. So follow me, do some few things, important things, and then show you exam questions. So the first is to import the data. This is a data set. So that's the first thing to do, to import the data set. Okay, so when you look at this data set, you import it after installing the pandas as PD. The name of the data, I'm calling it DF, but in the CSV file, it's labeled as Jim. You can use any name you want to use. And then this first command is just to look at the top 10 rows of the data, which is what you see down here, but I want you to run it. Okay. And I'm going to show just the first 4 rows instead of the 10 rows. You can do the same thing just to feel what you're doing. So this is the first 4 rows of the data. Let's see if that is going to show. Okay. Sometimes, in my case, as you can see, I've opened a lot of. Okay, so you can see that it didn't show this. Now it's picked something, and this is interesting. This is highly, highly interesting, and I understand what it's doing there. This is interesting. This is interesting. Let me see whether I'll run it again. And do you know why I picked this? Because that was the one we left, we ended with. So it is taking the 2 variable case, but we want it this time to take everything. So to do that, I need to go and ensure that I need to just change the data. I need to just edit and remove that portion. But I use a different listing, so I need to go back and let me just delete it from the other one. Because well, it looks like I didn't even. Oh no. So let's go to Python. But you guys should have your own data. The thing doing pepe. Oh, yes. Okay. So I just want to swap laptops. But have you opened yours? Did yours show?
Yes, sir.
So yours showed all your data sets, isn't it?
Yes, please.
Okay. It says that Excel is running into problems. Oh. Small time, Keke. This laptop is just, let me just box on. So I'm going to rerun this. It should show the entire data set. There you go. So now it shows the entire data set. And now I have some few questions quickly. So first question, which variables are categorical? I think you know that, we answered that. Which ones are numerical? You know that, we answered that. Which ones are float? Which ones are float? Justice.
So the price and the price, because it has points.
It's not,
And pardon?
what is You are, it's like you are done, but you are also continuing.
So and the M is also yeah.
Yeah, so why do you say just the price and then you can't say
Also.
All right, which ones are Boolean? Which ones are Boolean? Come on. Your programming for analytics, is it not being taught? Which ones are Boolean? Yes, Emmanuel.
Yes,
Emmanuel.
no, please, can you hear me?
Emmanuel is not ready. All right. There is no Boolean. Who is disturbing us still? Okay. Integers. Yeah, we have 2 of them that are integers. Characters. We have 3 of them that are characters. Dummies. We have 3 of them that are dummies. All right. Let's look at the contingency table from this data set that we spoke about. We're going to take contingency table. We've already explained what a contingency table is. I'm just going to create a contingency table and ask you some few questions related to that. The contingency table, I'm doing it for religion, location, and occupation all together. Okay. And here you indicate which ones are the columns. So you can see that the occupation is a column, whereas the first 2 are the rows. So if you run this cross tabulation, which is another name for contingency table, you get this result. You should run that and get your own result. So I can take this one in an exam and ask you, okay, in your assignment, I will ask you to run. But in your exams, I will run this and rather give you that. And when I give you this, I will ask you some questions. These are some of the questions I'll ask. So look at this and let's discuss. How many Buddhists are here? Who can tell us? Looking at the information, how many Buddhists are here? Raise your hand and tell me. Just.
So the Buddhists at 12.
Very good. Whilst we are going, somebody will not ask so. Then when we have finished everything, say, Doc, can you go back to 1960 and tell us how you got to the Buddhists? How many fishers are Christians? How many fishers are Christians? Hayford.
8.
Very good. How many teachers are Muslims in the rural areas? How many teachers are Muslims in the rural areas? James.
4.
How many Christians are here? How many Christians? Hayford.
12.
Very good. So you should be able to. Now remember that the contingency table I have here is very small. When you have in the exam, it will be so long left and right. So it's important to always be understanding them. All right. Next one. So that's how you generate contingency table. The next is to do the descriptive statistics. You remember we did it in Excel. So you can do it here. Simply type the name of the data set, describe.t.round 6. Round 6 means that you want the thing to be in 6 decimal places. But what does a T mean? What does a T mean, Eugene?
Well, Doc, actually, your screen has moved into the left.
So if you can please zoom out and then.
It's moving to the left.
Yes, Doc.
Oh.
I think because you zoomed in.
All right. How about now?
A little out.
A little
I think
out.
you should move, you should swipe to the right. Yes, you should swipe a bit to the right. But
There's nothing to swipe except I zoom out.
You
okay.
can take from your side.
Sorry?
Oh, okay. Okay, I see now. Yes, it's better now.
All right, okay. So this is, I was asking, what does the T mean? The T means transpose, okay? So if you want the analysis to be vertical, then you use a T. If not, you leave it. Those on the far left will rather go on top, and then they'll swap. Okay. So let's start with the questions under them. This is a descriptive statistic, and you can see that it's only for the numeric variables. Question, what can you say about the standard deviation and the mean of the distribution of Q and P? So look at the Q. The mean is 175. The standard deviation is 30, 29, almost 30. What does that mean? Since the mean is bigger than the standard deviation, it means that there is not much variability in the data set for that Q. Okay, there's not much variability. Now, sometimes you check the minimum and the maximum value. The minimum is 130. The maximum is 220. So again, there is not that much variability. I suppose that the minimum was like 4, 5, 7, 20. Then you know that there's a big gap and hence high variability. What about price? Price too, when you check it, there's not much. Look, here's a point to take note. Anytime the mean is less than the standard deviation, there is a lot of variability in the data set. Write it down. Anytime the mean is less than the standard deviation, there's a lot of variability. In the same way, if the mean is not is above the standard deviation, there's not much variability. That's all. You can also do the descriptive statistics by group. So you can run this. Okay. So by group here means that you want it to give you the descriptive statistics, but you also want it to do it for each group. So when you take Buddhist, you check the mean and the median and all of those things between Buddhist and among the Buddhists, between rural and urban. Okay. So look at it, among the Buddhists, you can see that the urban consume more than, and we are looking at kale, by the way. So kale is a quantity demanded of Akbatashi. So you can see that the urban people rather consume more than the rural folks, unlike you thought. And what does the value of this standard deviation mean? You see, the value is 0. So what does it mean when you have a 0 standard deviation? Hold it down. And you can see that in this very case, that's the case. And there's a clue that will give you, that should help you. It's a beautiful clue. What does it mean when you have a 0 standard deviation? Do you see something, Samuel?
So I can try. It means there's no variation.
Of course, it
The
means
values
there's
are
no
the same.
variation. Of course, it means there's no variation, but what does that imply? It means that when you go and check the observations, all of them have got the same value. That's it. So, see, if you were quick enough, you would have noticed. Look
So
at the.
I added that one. I said all of them have the same values.
I didn't hear. So if you check the minimum value and you check the maximum value, they are the same. So that means that among the urban, there is perfect, mean. And that means that there is not a single variability in their consumption of. These are Buddhists anyway, so understand. The next one is Christians. So when you look at Christians, okay, among the Christians, we have the urban, rural, and so forth. And you can see some differences and things like that. So this is what you can say about these very examples. The main thing you can notice is your ability to classify them by groups. And it is important you learn how to do that. Now, you remember some few minutes ago, we said that you can also check for the normality of the data. Is the data normal? So you have to take each variable and check whether it's normal. So here we can check whether K is normal. You remember we said we should use the Shapiro-Wilk test. But first, before we do that, we want to use graph. Okay. And one graph you can use is a histogram and the kernel density plot. So this command will create the histogram and the kernel density plot for you. For which variable? K, quantity demanded. And you get this result. I'm going to show you a similar one where you do other graphs. But before we go to those other graphs, look at this one carefully. This is quantity demanded of generators. What does that tell you in terms of normality? Just looking at the graph. What does that tell you in terms of normality? Is it normally distributed or is not normally distributed? And why? Is it normally distributed or not? And why? Yes, Lucia.
I think it's normally distributed because it kind of looks the same.
Okay. That is not correct. Not correct at all. But you made some attempts. How many peaks does the kernel density plot have? How many peaks? Justice.
So please, it has 3 peaks.
Yes, what?
It has 2 peaks.
Yes, 2 peaks. So we call it bimodality. So what does the fact that it has 2 peaks tell you regarding normality? What does the fact that it has 2 peaks tell you regarding its normality? What does it tell you? Multiple modes. No, the one who typed didn't give it. Well, it simply tells you that it's not normal. That's all it means. Okay. It's not normal. Normal distribution is unimodal, one mode. I mean, one bar. If you can all remember your statistics carefully, the normal distribution goes like this. Tell your colleagues who have left the call to rejoin the call. All right, so you can use these commands. All of these commands, you can combine them to show 4 graphs at the same time. The first one is indicating whether K is normally distributed. Graphically, it appears it's not. The second one is box plot. Box plot here is telling you across the groups, which of them have got a higher consumption pattern of aquatation. So you have the box plot for Muslims, Buddhists, and Christians. Okay. From the box plot, you will know that which group is consuming a lot, just statistically speaking. Not what you feel, but statistically speaking, just using the box plot. Which group is consuming a lot?
Buddhist.
Yeah, you aren't really thinking. Because if you were, you would have really known what is up. Which group is really, really consuming a lot and why? Justice.
So I'll say the Christians,
Why?
because you realize they are almost at 220 on the y-axis.
Very good. That's it.
Yeah.
You use the black line, just so you know, you always use a black line and compare the black line for each box. The black line represents the median. The black line represents the median. The first quartile, the 75th percentile. So that's the upper bound. The upper bound of the box is the 75th percentile. The lower bound of the box is the 25th percentile. So when you look at the center is the median, which is the 50th percentile as well. And when you look at the median, that of Christians are more than that of Buddhists. However, there are a greater percentage of Buddhists who are consuming the aquatation than a greater percentage of Christians who are consuming aquatation. In other words, there are few Buddhists consuming, but those who are consuming a lot. That's what it is. And then you can also use the quantile normal probability plot, this one, the KK plot. When the blues are seated beautifully on the reds, then the data is normal. When the blues are seated on the reds, the data is normal. Okay, but here, they don't sit, so it doesn't look like it's normal. This kernel density too, we've already spoken about it. The fact that it has multimodality, two mode, means that it's not normally distributed for Q. Okay, so that's what it means. Now we can use a test statistic, the Shapiro. You use a Shapiro to check whether it's normal or it's not normal. All the above are great, or they are great, but you have to prove that statistically. So run this. And after running it, the Shapiro will give you a value of 0.91. When the Shapiro is 1, it's not normal at all. So look at the p-value and write this down. In the Shapiro test, when the p-value is less than 5%, the data is not normal. When the p-value is less than 5%, the data is not normal. So looking at our own, would you say it's normal or it's not normal? Looking at our own, is it normal or is it not normal? Remember, when the p-value is less than 5%, the distribution deviates from normality. Richard?
Yes, so this one is 0.03, so it's less than 5%, hence it's not normal.
Very good, it's not normal. Okay. So that is what it is. Now, the last one we're going to end with today is correlation. You remember we spoke about correlation. So now we're going to generate a correlation. This command is a little bit detailed command I've documented for you, but it's a step-by-step. Let me just show you. First, we need to remove all the categorical variables. So that's what this command does, and creates only a new data set for the numeric variables. Then we create an empty data frame to hold the correlation values. So these are the empty data frames. Then this next command will just create the correlation matrix itself and then add the p-values in a box. Okay, this box is what is known as a heat map. So the final heat map is done this way. All the last three things are simply to show you the title. But hey, this is the best heat map you can ever. You can even put this in your long essay or thesis or journal paper. This is a heat map. For each one, there is the correlation value and the p-value. For each one, there's a correlation, but this one is too big. The numbers are tiny looking. So I did another one here. Okay. And then another one here. Of course, it has a small number of code. It has a small number of code, but please note that the code above will all be needed. So look at this carefully. It's the same thing here. Each correlation value has got a p-value. Its correlation coefficient has a P. So look at it and answer the next few questions. We're going to answer these next few questions, and after that, we are done. Let me see this. Oops. Yeah, after that, we are done. So first question. Which variables are perfectly correlated? Perfect correlation. I said it in my this thing. Which variables are perfectly correlated? Remember, perfect correlated variables are those with a correlation coefficient of 1. So which variable? Justice.
Say, quantity.
Quantity.
Then
say it in pairs. You have to say quantity and quantity.
Okay, quantity and quantity. Then the complement and complement. Then the M and M. Then E and P, price and price. Yeah.
Okay. Very good. Next one. Which three? Okay, I think we've looked at that. Yeah, Lucia.
So if you try and go back again, you were saying perfect correlated value have something of 1.
Master, tell her. The guy who answered the question, help him.
So they have a P of 1.
Thank you, P value of 1.
Okay, next one. Which two pairs of variable exhibit high correlation with the response variable? Which pairs of variables do high correlation with the response variable? By the way, which one is the response variable? Or which one is a target variable here? Which is a target? It's quantity. It's quantity. So the question says, which variables is highly correlated with the quantity? So in this case, you check the quantity column. You check the column for the quantity, and then look for all the variables that are there, and look for the biggest one first. So which pair? Q and what? Hayford.
Q and C.
Q and C is the first one, no. Eugene.
Q and P.
What is the coefficient? Emmanuel Kumson.
This is Q and P.
Coefficient.
0.87.
You should add the negative. You should mention it.
Sorry, negative 0.87.
The next one. Which is the next one?
The next one is Q and
Q and C.
C.
Q and C. You know why Q and C is the next one?
It has, because after the negative 0.87, it has a coefficient of 0.72.
0.75. 0.75. Very good. Very good. So that's how you identify. Let's look at the last bar too. So what does this tell you in terms of predict? Okay, forget about that, because this one, which two pairs of variables are multicollinear? Remember,
So please have a question.
Yeah, go ahead.
So we are dealing with absolute values, right?
Yes. You're dealing with absolute value, but when you are writing, you don't forget the sign.
Okay. Because the negative is, I don't know, the colors are actually showing higher, like negative. So I don't know, the fact that it's negative, I was assuming because it's like blue, very blue, it means it should be the last.
The color means nothing. The color only tells you the intensity.
Okay.
All right. So, which pairs of variables are mostly multicollinear? The definition of multicollinear is those variables that independent variables, which are highly correlated with each other. Independent variables. Remember, it doesn't include dependent. So this column will go because that column has dependent. This column will go. So that column has dependent. You are just looking at the it's having noisy environment like that. The people who are not serious, they don't talk, they even don't know what's going on. They are the ones, because if there's noise in your background, you know. All right. So who can tell us the first pair that is multicollinear, highly multicollinear? Justice.
Say P and P, C and C, M and M.
Mention the numbers, or just the letters.
Okay. They all have a 1.0 p-value.
Don't be lazy. Mention the exact number of
1.0.
That's wrong. I say high correlated. I didn't say perfectly correlated. Mano.
Okay, so there's the P and C.
What's the value?
Negative 0.74.
Good. And I'm sure the next one is what?
The next one is C and P. Okay, the same thing. So the next one will be C and M, sorry.
C and M.
Yes.
Good. That is 71%.
Yes, please.
Perfect. So now you should know how to. If I had said the least multicollinear, which one would have been the least multicollinear? Which pair? Least multicollinear. Least multicollinear. Justice.
Say M and P. And P they have a p-value of negative 0.51.
P-value. I'm interested in the coefficient. Now.
Okay, a coefficient of 0.51.
No, that's wrong.
Negative 0.5.
Sorry, negative 0.51. Sorry.
It's very important. I hope you don't write that.
Yes, sir.
Okay. Which three pairs of variables are least correlated? So just tell me the least correlated pair. The least correlated pair. Okay, no. Yeah. The least correlated pair. It will still be that same one you just mentioned. Because the least correlated means that you are looking at everybody, even including the Q. Least correlated. But then the least multicollinear, you're looking at only the independent factors or the features. Write it down, you forget. There's a scatter plot matrix that you look at when it is at the appropriate time. But the most important one is knowing and understanding and explaining. Now, if you want to check whether each of these correlations are significant, you use what? What do you use to check whether the correlations are significant or insignificant? What do you use? Use the p-values. Use the p-values to check whether the correlation is significant or insignificant. Okay, that is what you use to check whether the correlation is significant or insignificant. Any question? Any question on anything on this correlation? Any question on anything regarding this correlation?
Hello, Prof.
Sorry?
This even know. So in this case, does it mean that
You sound far.
please can you hear me? Yes, I said so. In this case, does it mean that the ones that have significant correlations is the ones with the p-values of 0.001?
The one that has what? If the correlation
Is significant.
is significant, then the p-value is less than 5%.
Less than 5%.
So the one with the most zeros. The most significant. Did you get it?
Yes.
The one with the most zeros. Okay. Any other? The one with the most zeros. One with the most zeros. Okay, so guys, these are the key important things that you want to know when it comes to this correlation and descriptive statistics. Next time, we're going to proceed by looking at the regression. The regression will just establish causality. It will establish causality for you. Now, also learn about scatter plot metrics, because scatter plot metrics just pick, it's the same as a correlation matrix. The only thing is that it rather draws. So here you can see that if I want to know the relationship between, look at this one. This last one, bottom here is kill, and then here is complement. So if I want to know the relationship between the kill and complement price, I just use this one. And when you look at the graph carefully, it looks like it's a little bit positive. Okay. So these are what you normally use to just start preliminary work. And when you look at the variable, so look at a variable like price, okay? It also, so this graph, and the good thing about this graph is that it tells you how the variable looks like. So if you look at this quantity, this was a distribution we talked about, the normality. If you look at price, this is it. This is how it looks like. If you look at complement price, that one looks like multimodal at the top. The hill comes at the top. If you look at income, that one is very, very not normal distributed at all. In fact, it appears that most of the variables are not all that normally distributed. But this scatter plot matrix will give you a sense of each one of them. Now, next time we're going to look at the regression, and then we'll now come to a proper understanding. Ladies and gentlemen, that brings us to the end of the entire caboodle.